In this example, we are to sketch the graph of the following function, and that function is f of x equals 2 times x minus 3 squared minus 4, and then state the domain and range of that function. So right now, this is in a nice format for us. It is in vertex form, and that tells us a lot about what's going on. So let's take a look at what it's showing us. So vertex form is y equals a times x minus h squared plus k. And when it's in that format, we know the vertex and we know whether it's concave up or down. So the vertex comes from the h and the k, and the k is whatever the number is at the back, and the h is the opposite of whatever's here. So it's minus h, then the h is there. So if it's minus 3, a 3 goes here. If it's plus 3, then a negative 3 goes here. And what else do we know? Well, we know that our a value is 2. That tells us that it's concave up, and it tells us that it's a little narrower than normal. So a is greater than 0, concave up. So from that, we can know our vertex is 3, negative 4. And we can plot that point. We also know the axis of symmetry is always whatever your x value is. So we can put that on a graph right away. There's our vertex at 3, negative 4. We know it's concave up, so it's going to look something like that. That means we're going to have 2 x-intercepts, and we're going to have a y-intercept up here somewhere. So we know all of that even from without doing anything, just from what we're given in this question. Let's see, what's the next step? Well, we need to find another point. So an easy point is to find out, well, what is that y-intercept? So whenever we're looking at the y-intercept, x equals 0, because everything on the y-axis is x equals 0. So if we substitute 0 in for our x, and then all we have to do is solve that to find out what our function will equal. So when we do that, we get 0 subtract 3 is negative 3. Then when we square that, we'll get 9. And then that 9 gets multiplied by the 2, and then we subtract 4 from that to get 14. So when x equals 0, the function equals 14. So that means our y-intercept is 14. Now that we know that point is the point 0, 14, it's easy to find another point because of symmetry. We'd have to have another point at the same spot over here. And that's easy to find because we're 3 steps away from the 3 steps away from the axis of symmetry. So if we go 3 steps the other way, then we can put down another point. So that would be the point 6, 14. Now that we have 3 points, we could easily draw this. Again, a little difficult to do when you're working on a computer, but it's just a curve that goes, you don't want straight lines, you don't want this to be a V, you want it to look like a parabola, which is a nice curved shape, looks something like this. And because it's a sketch, it doesn't have to be perfect. We don't have to have all of the lines on here to show that this is exactly 14 units up. As long as it's close, then that is good. Now, before I do the domain and range, let me just show you one thing. This right here is the point 6, 14. That means if we put 6 in for x instead of 0, we would have 6 subtract 3, which would be 3. And when we square that, we get 9. So of course the rest of this will be the same, and that makes sense that we get the 14 again. And that's what happens all the time when we're working with a quadratic function. Now the domain, your x, is always the same. There's no restriction. And the only restriction for your y is that it has to be bigger than the y value of your vertex. So y is greater than or equal to -4. And of course, I meant y is an element of the real numbers as well.